I bet in 20 seconds we will be.
Yeah. I think. 1 second. Still waiting. I think to start on YouTube, but it should be working in a half a minute, like exactly at the time. But good morning, everyone. Still, and uh, yeah, how is your morning, guys?
It's not Friday, as we were talking about just a couple seconds before, but Saturday is also good. Also good.
Mhm.
Spring is here. I don't know how it's in the Netherlands.
It's quite cold here, to be honest. It's 13 degrees. Yeah, it's quite sunny, and yeah, it's not that bad. But the wind is Nordic, so it's quite cold outside.
Well, typical Netherlands summer, right? No.
Yeah, that's right. Yeah, welcome everyone again. Was Yeah, it's a pleasant morning again. I think nowadays we go live every Saturday. To be honest, I'm very proud of this schedule myself. So today I think is our officially 26th live stream or event or meetup, whatever you call it. And today we have Evgeny as a special guest, our expert invited. And if you remember, I hope you remember, he was here 2 weeks ago with the first part of the workshop about this bicep. Yeah, I think in general we can say that that was the first part where Evgeny explained basics, including some DevOps basics, including Azure DevOps basics, and also uncovered a little bit of bicep technology. And today, yeah, I think Evgeny will present it in a minute himself. But today, the idea is a more deep dive into the bicep and see a real use case with a real application scenario that again was introduced last time.
Looking forward.
Yep. Yeah, check. By the way, I would say that with this type of weather, because typically I go for cycling on the weekends, so I prefer to do the proper road cycling. But yeah, I would rather skip it today with this wind and with this type of temperature outside. So it's better to stick with you guys and proceed with the second part of our bicep journey, where we try to deploy a full stack application using bicep template technology to Azure environment. Yeah, so yeah, I'm looking forward to start. Whenever you're ready,
Yeah,
just let me.
let's go. I think we're ready.
For
Yeah.
sure.
Yeah, maybe a quick sanity check. Can you see my screen? I'm showing right now the Visual Studio Code, and that should be getting started with Bicep.
Yeah, we can see that a little. If you zoom it in a little bit, that would be awesome. Yeah, I think this is perfect.
Okay, perfect. So what I'm gonna do now, I'm gonna do a little recap what we did last time. Yeah, just to make sure everybody's on the same page. Um, if there is a question or comment, or you really want to make a remark, so there is a question box, I believe. Just feel free to do that, and yeah, I'll try to address it. So please keep in mind, I don't really have a second monitor at the moment, so I can't really look at this question. So I would rely on help of my colleagues. Yeah, so basically, if there's something that needs to be addressed, please do let me know.
For sure.
Yeah. All right. So maybe I can scroll down a little bit and show what we are going to do at the end, what we actually will have at the end. So this is a little application reference that I've just scratched, and then so the plan is to use Azure's environment and deploy VueJS as a client. So that's going to be my client. And then I have also a Python application using Flask framework. So that's a tiny but really smart web framework that I use for the Python application. And Python and Flask in this case plays API role in my application stack. And then I use the Postgres as a database to keep the content for my application. So the plan is to use Bicep templates. So we're gonna explore different type of resources. We're gonna build our templates, and we will see how we can connect our resources in the most smart way. For example, so if I want to consume images from the container registry, because this is the resource that I will use for my application as well, because Flask will be in form of Docker container. So we will build it, and also we will store it in Azure Container Registry. So I will use what is called a managed managed identities, or managed identity, which is another resource from Azure, which will help my my infrastructure for Flask application to pull that image from the container registry, because it's a private container registry. So I need some sort of authentication with it, but I will use a credentialless approach, or the best practice that Azure recommends. So basically, managed instances, or managed identities. Sorry, that's basically the end goal of today. So we will have the application running in Azure using this using these technologies, and we will deploy that using the templates. So I will also use the GitHub for that. So we will use the GitHub for the source code, and also GitHub Actions to basically to run the build, and also to run the deployment process on the GitHub agents. All right, let me scroll up a little bit, and then make a recap of the previous conversation, or the part 1, where I talked about Bicep in general. So if you look at this picture, so basically Bicep is a open source DSL, or domain specific language, which is defines to build the infrastructure as code, or YAC, or IAC in Azure. So Bicep is only for Azure. I think there are some plans to extend it, but at the moment it's only for Azure. And then if you look at this picture, so this is kind of high level view how things are working with the resources in Azure. So basically, you have what is called the Azure Resource Manager in the middle. And then you can use Azure Resource Manager with a different tool set, like for example, when you work in the Azure portal, so basically you use buttons and the UI interface to request your resource. At the same time, when you use a Bicep file, or when you use IRM template, you define the resource stack, or the resource set that you want to build in the file. And then when you submit your request, you also hit Azure Resource Manager, which basically further then use the resource providers to create the different resources that you requested, either via the portal, or via the Bicep file, or IRM template, or any other approach. Let's say if you work with a declarative way, like Azure PowerShell or CLI, when you declare what you want to build, you also hit what is called Azure Resource Manager. So we also talked about some advantages in the previous session. Maybe just a quick highlight of those. So Bicep gets everything supported from day one from the API perspective. So every version of the API, both for GA and the preview status of the service is available from day one. It's much simpler. So if you come from the IRM templates, then it's much simpler for you, and we will see that in a minute. So it's like less parentheses, less curly braces, commas, etc., and less code at the end. It's a first-class citizen using Azure Experience, using authoring experience. There are a bunch of extensions available for that. So for example, I will use Visual Studio Code for building my templates today, and you will see how it's cool, how it is suggestion what to do. Like there are some linting embedded in it. There are also some predefined schema or a skeleton that define certain resource. So I can just simply fill out the fields and then submit my template. So the Bicep intention is to be idempotent, which means that every time if I submit the same template, it gets the same results. So it's an orchestration, meaning that the order of resources doesn't matter. Of course, you have things like depends on, for example, or you have reference to other resources or inter-reference between resources. And the RM or Azure Resource Manager decides which order should be correct, and make sure that the resources are created in order so you don't have any problems on the way. So modularity, so we will break the templates, we will break our deployment into a number of templates. If you take a look at the screen right now, we get a models folder, and then these are the models that I will reuse. So for example, web application, static site, Postgres, Key Vault, it should be ACR, Azure Container Registry, but it doesn't matter how you name them or how you structure them. You can even combine multiple resources into one and say, if you look at the web app, so web app is actually more than just the web app. It also includes the managed identity, ACR pool role definition, the role assignment, things like that. So models, it's up to you how you define. It's typically the logical parts of your application, and it doesn't need to be stick with the resource, like individual resource in the model. Anyway, so that's modularity. Now the benefits: integration with Azure services such as Azure policy templates, specs, and blueprints. That's pretty cool. So especially when you do validation of template, it also goes to the Azure policies, checks whether your template is good. So whether you do not go against some constraints or policy violation. You can also keep the Bicep templates in the template specs or also in Azure Container Registry, and then you can use that kind of single source of trust to deploy your templates by just providing the parameters for those resources. You can also preview what if operation. You can preview the changes, what kind of changes will happen to your infrastructure after applying the template. So there is also no state or the state file to manage the state of your deployment. Everything is stored in Azure. And there is no cost because it's open source. We also looked at the way to basically to do the contribution and what are the current issues the Bicep has. So maybe you have some ideas and skills to help out with the beauty. We also looked at the Bicep and IRM way of working. So I basically explained this is the example of the template. So we have a storage account over here with a couple of references. So we also kind of deploy that a resource to Azure, and then before that we did some validation and checked what if we deploy that to see this the changes that the template will apply to the Azure environment. We also looked into the export method, which is pretty cool to see how exactly a certain resource or a certain set of resources made of, like what they are made of, to see the actual the actual underlying template, which brings back the JSON specification to you, and then you can use the decompile operation to get Bicep out of JSON. So then we talked a little bit about the target of the scope or scope target. So the Bicep template you can deploy to the following target scopes. Actually, you can deploy to subscription, to resource group, to manage group, to management group. And then these are the type of resources that you can deploy to, and tenant, of course. These are the type of resources that you can deploy to those scopes. We also talked about the default scope. So the default scope or target scope for the template is a resource group, if not defined otherwise. And then this is the typical a bicep template structure. So where you have the definition of the target scope, then you have some parameters, and sometimes you may use decorators. I will also look a little bit deeper into decorators in one of the exercises here during the workshop. Then you have the variables, then you have the resource definition itself. Then because modularity, you have also the ability to define a model, and then there is a reference to a certain path, let's say models and a path to one of the file. And then the outputs, it's pretty cool. And so when, for example, you get a resource created with the output, you get some, you can get the outputs from that resource. So for example, you want to get the fully qualified domain name or FQDN from the public IP address or from your web application. You can do that via the output. So you can define resource and then go through the parameters of that resource to get the desired parameter or attribute. So I also suggested to look into the Bicep linter. So there are some default Bicep linter rules, but you can extend that if you think you need it. So the Bicep linter is taken from the IRM dedicate test cases. So the dedicate is actually a test framework for IRM templates. It's quite a common practice to use them, especially in DevOps cycle. Let's say if I deploy something in Azure, if I deploy infrastructure, I really want to make sure that my templates are valid. And IRM TDK is kind of out of the box from Microsoft's framework for doing that. So then we also looked at the APIs. I also showed you how to using the Postman, for example, or curl CURL, how to fetch data from Azure Resource Manager via the REST API, or how to submit your payload and create some, let's say, some resource, like we created the resource group in Azure using Postman last time. Also, I highly recommend you to explore AZ REST. So the AZ REST basically is a command line. AZ is basically a command line interface or CLI, and there is a method REST in that CLI. So it simplifies the use of REST API significantly. So you can also generate token over there and use that token, for example, to your CURL, maybe in your script, or you can see. So basically, it kind of a wrapper on top of this URL that might be cool to explore. All right, so this is it. And we are in this application reference right now. So I guess that was a quick recap, and let's just go to the next step, which is Azure CLI configuration. All right, so I might just quickly check where I am at the moment. All right. So I'm just checking that I'm working in the right subscription in the right tenant, because I do have several subscriptions, and so most of the work that we will do with the templates are from my machine, because we want to explore it, we want to experiment it. So I just want to make sure that I do have everything. So I will deploy that to basically to the right subscription, to the right direction.
Evgeny, by the way, do you use a temporary subscription, or you have some specific Microsoft account?
So I do have a MSDN subscription, or Visual Studio Enterprise subscription. So yeah, it's like refilled every month, 130 euro credits, mainly for the experiments for playing with the with the Azure resources, and I received that because of the because of certain status.
Nice. Cool. I had one question when you were explaining the target deployment. I'm not sure if I fully understand this
Mhm.
destinations, let's say, of deployments. If you can say one more word about that.
Mhm. Sure. So the target, basically, in Azure, you have different scopes. So, for example, you have a scope of tenant, and then under this tenant, you get the root management group. And then under that root management group, you have management groups. And then under the management groups, you have subscriptions. And then within subscriptions, you have resource groups. And then in those resource groups, you have resources. And when you deploy your templates, you can choose any of these scope. So, for example, most of our deployments today we will do to this resource group scope. But if you want to do the, let's say, if you want to deploy and if you want to create a management group, for example, and if you want to do that via Bicep, you can define Azure AD tenant as a scope. And then in your template, you can specify the management group parameters. Let's say, the name of the management group, the properties, etc. And by the way, if you look at this, go ahead.
Yeah, so it's not only namespacing, but also on each level of this hierarchy, you have specific objects, specific resources that you can deploy to. Okay.
Yeah, as on this picture. So on the right hand side, you have a list of resources that you can deploy to to a specific scope, to a selected scope.
Okay.
So here you have I'm just looking at this.
And overall, this hierarchy is basically a way to somehow distribute like the access management for the company, right? Like for the like divided to projects, to teams, something like that. Is that the?
Yeah, so the role-based access control you can define on subscription, on the resource group, on the resource itself, or on the root or on the management group. Yeah, that's indeed how you typically define who can access what, or even with non-personal account, or it's in Azure it's called service principal or service principal. Also can use the same approach. Like you can also define what exactly your service principal can access.
All right, thank you.
Yep. So by the way, here's the example of the subscription scope. So you get a first thing, which is a resource group, and then you have a target scope subscription, and then we just deploy a resource group to the target scope of So we deploy a resource group to the subscription target scope. All right. So what I wanted to do first, so I quickly wanted to show you the application itself. So, but before that, let's just make sure that we have everything set up correct. So we got a Azure group, Azure account set to the proper subscription. So basically, we can deploy using all other steps here, and we don't have to worry about incorrect destination. So let me do the first step. So the first step will be prepare the database. So for the database, I will for the database I first would like. So let me explain first. So first, I would like to quickly start up the whole application locally, so we can take a look at the full stack of this application running on my local machine over here, and then we will use Bicep to do the same in Azure. So the first step would be to start up Postgres. So Postgres, for the development purposes, I will use the Docker. So I do have Docker installed, and I already have this Postgres up and running. So this is how I do it. And then if I want to connect to this Postgres, I basically want to use the client just to make sure that I have everything there. So I have it's an empty database, so there is nothing. But what I want to do now, I will just quickly use this little database schema that I want to use for the application. So let me just quickly walk through this. So the first piece is quite clear. So we create a database called abw_database. And then we create a table that contains a title, author, page number, the Boolean attribute read or not, and then the date added for the current timestamp. And I also have 3 books that I will add that I will seed in my database. So the first will be the Phoenix project. And then, some other things. So let's just quickly let's just quickly restore this. So for that, I will just use commands that I don't really remember by heart, but I will do.
I don't know how is with a PostgreSQL, but with Oracle, for example, if you start it locally in a container, it most of the times it can cache your data between sessions, so it's also quite handy for local development. But I don't know if Postgre can do that too, I guess.
Didn't explore that further, but let me just quickly restore the content that I just showed you. So for the database password, we use secret because we provided that. So let's just connect and validate. So first, yes, we do have a database over here. So let's just connect to this database quickly. And let's see if in the books I do have all the books. Okay, perfect. So the setup of the database is done, at least locally. So we'll come back to this step in a while when we start to do exactly the same for Azure, using Azure for PostgreSQL. By the way, if you are not familiar with the PostgreSQL, just go ahead and explore the documentation. Alternatively, I found something quite handy. So there's actually, if you go to the Postgres, oops. To the Postgres Docker Hub. So you will see different ways how to run it, and they also offer the tool which is called Adminer. So with Adminer, you actually get this kind of interesting web-based UI experience where you can do exactly the same what I just did, at least create a database and also do some queries. All right, so I'll leave this for now. So my next stop will be the server. So as I stated, so the server that I prepared is based on the Flask. So let me just walk through this super quickly. So first of all, I use Flask version 2.0.0. And then I also use the course. So course is for the cross-origin requests, because we have the VueJS sitting on a separate IP or on a separate machine, and then we want to allow the client to query our API. So that's why we use this package. And then we also use the SciCop. That's for the PostgreSQL. So basically, that's the package that helps me to work with my Postgres. So here's the Python. Everything is super simple. Of course, there are a lot of ways to improve this application, but again, the purpose of this exercise is just to see how this application can be deployed to Azure. So let me just walk through the through this example super quickly. So we use the Flask, as I said. There are a bunch of libraries that I defined over here on the top. So I immediately enable course, and I also have the like a health check or the the health check endpoint that I can use in order to check my application whether it's healthy or not. So then I also have the piece or the method that I use to connect to base, again using that package. By the way, I get the environment variables to use that. So let me just quickly show you. So I actually have them already. Oops. No, I don't have them set yet. So we will actually set them now. So then we use several routes. So we use the routes for the books. So we basically want to fetch all the books, or we want to post a new book. For that, we connect to the database, use the SQL query to insert the book parameters or book details to the book itself. And then we have another method which is get to fetch all the books and get the form of JSON here. So then we can do something with that. Then we have another two routes. So we have put for update, and then we have delete to delete the object from the database. So we have the put method over here. So to update, so we use the SQL query to update either title, author, or pages, or read. And we also have the delete method to delete from the database the that we don't need it. So then we execute it on this port. So basically, the Flask application. So let's give it a try. I believe it's not going to run because some of the environment variables are not set yet. So, but at least let's just quickly check whether it's up and running. All right, so I think I don't have this route defined, but at least I have this health. So let's also quickly check whether books giving me anything. No, it doesn't, just because most of these things are not defined. Let's just quickly define all the environment variables that are needed here. So if I just check here, Postgres SSL mode equal to prefer. So basically, it's either I enforce SSL connection between clients and the PostgreSQL or not. So I did to prefer, meaning that well, it can ignore because it's for the local development purposes. I can ignore it for now. So the way we export variables is and set down to the environment variables is like this. So we want Postgres host first, and then we want this local host, and then we also want to define port. So the default port for the PostgreSQL is 5432, and then we also want to define password. So password is super secret. Then we also want to define user. So user is Postgres. And then what else? And I think that's it. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we also need a database name. Yes. So the database name. So we agreed that it's going to be a database abw_db. So let's also set this environment variable to the name abw database. All right, so now if I run Flask again, I actually should be able to see something. Yes, there you go. So these are basically all the books that we defined that we seeded in our database. Let's also go here. Maybe I can just create a quick request folder. And I add request over here. So I will just query localhost All right, so these are my books. These are my books. I can also do a quick check whether my post method works. So I will do that to the books, and then I will do a bunch of attributes as well. So I want a title, for example. So the title would be unlimited memory, for example. Do I have this book already? No. All right, and then the author would be John Smith, and then the pages would be 149, and then the red would be true. Oh, yeah, true, because I've read this book. All right, so if I submit it, so let's see if I, no, that's these are the old methods that I have. Oops. I think it's should be.
Igor, you have experience with Flask?
A bit of, yeah, but I don't remember by heart like the syntax how you do it.
I think it's already set to use to parse the JSON and get the values from the client. Let's actually skip this for now because honestly, I didn't check with the postman. However, at least it returns the values if I just simply get it from the database. So the add method needs some attention, but we will revisit that a little bit later. So let's just keep going. So at least we have the server up and running. So yeah, let's take a look at the client. So for the clients, I do have the following application. So basically, it's VueJS, and I use the VueJS CLI to generate, so basically to scaffold the application. I have 2 routes. So I have again the health check route to ping whether my backend is healthy, and I have the route for the books. So we go and check the ping route. So we use the base URL, which is my backend URL. We use the Axios package to do the queries, and then one of the passes is the health. Yeah, just to make sure that the application is communicating with the backend properly, and the backend has everything up and running. And then I have the books set of methods. So here, basically the methods to have like the standard set of methods: create, update, remove, delete. The CRUD set of methods. So the way I run it is basically npm run serve. So should be available on localhost 8080. So let's give it a try. Let's see. Right, so at least it queries this. It queries the backend. Let's see if I can actually see something. So in the books, it calls the localhost 5000 for the books to fetch all the books. And if I, for example, submit that book unlimited memory, John Smith, and then if I set it yes, and if I submit it, well, via the client it works, I think I need to look into the way it parses the the JSON, the payload. Anyway, so it works. I can add the book, and I can list all the books, and it all goes from my Python application. So we see that there are a bunch of requests going on here. So we just use the get method, and also we posted a new book. So maybe another easy way to quit smoking. I think it's Alan Carr, probably. Yeah, this is a non-technical book that I still remember because I used to smoke in the past quite heavily, and then I read this book and I stopped smoking. Quite funny, but thanks to the gentleman. So looks like it works. So I've added a bunch of books, and I can also output them here. So now this is all running locally. Yeah. So the idea is to basically to create a database in Azure for the backend for the Postgres, so I can do exactly the same. I can store my books, and I can also query my books. Then I want to use the web applications. That's the PaaS, or platform as a service from Azure, that will run my Python Flask application. And then for the VueJS, I will use the static site, or web static site. That's the service to basically to run the client. The static sites, there are some frameworks supported out of the box, like React, VueJS, the plain like JavaScript, etc. So let's get started. So let's go ahead and move to this step. Let's mark down. So the first step will be for me is to deploy the resource group. We already seen this piece earlier when I talked about the target scope. So basically, I will use the subscription as a target scope to deploy my resource group. So the reason being is that I want to use the tags, and I want to define my tags in the parameters. So if we go ahead over here, so I have this initial parameters that I will use for my deployment. By the way, this is how you define parameters in the file. You can also provide parameters at your deployment for your templates from the command line. So basically, you can define with the attribute. So let's do the first step. So let's first check whether we don't have anything in our Azure environment. No, we don't. I just want to quickly double check whether I don't have anything in my key vault, because if you delete the key vault, it also goes to this soft delete method. So it's still available, but you can restore, meaning that the key vault name is reserved, and you cannot deploy the same key vault with the same name, because the key vault name is the unique across the whole Azure environment. Okay, so my first step would be to, as I said, to deploy the resource group. And also, what I would like to do, I would like to restore, I would like to deploy the Key Vault. So the Key Vault is basically a service in Azure that helps you to keep your secrets like passwords or the token, also certificates or the key stores in a secure way. And then you can consume them from other resources, for example, or in your DevOps cycles. So in this case, we'll create a Key Vault, and also I will use I will create a Key Vault, and I will also use the modular approach over here. So let me actually show you the first template file. So the first template file will contain the research group itself, so which will be deployed to the subscription. We provide the location, the research group name, and the set of tags to this deployment. So I already mentioned these parameters over here. So some of the parameters we will take from here. Some parameters I will supply via the prompt. So there will be prompt shell, and I will just add parameters over there. Yeah, I will basically deploy also the Key Vault. For the Key Vault, I have 3 parameters that I supply to the resource as well. So the database user, database password, and the token. So the first 2 are used for my PostgreSQL for the connection. So I actually would like to specify the username and password myself. So those username and password will be stored in my Key Vault, and then I will consume them while creating my database. So my database will have this password and username set in itself. And then later on in the web application deployment, they will be set as environment variables, and my Python application will also use them like we define here. Like we define in our Python application here. So it's the same application. It will just use the environment variables, and those environment variables will be stored already in web application. So yeah, maybe a quick walk through the Key Vault model, because this is, by the way, as you can, if we zoom in, so here we define the resource, yeah, and then we define this symbolic name, RG, and then we define the resource itself, which is up until here, and then we define the version. So over here, we define a model, and the model is like this. So you define a model, and then the symbolic name, and then the path to the model. So the symbolic name helps you to make the reference in your template in other models. Like for example, here, I do have a resource for the RG, stands for resource group. And if I scroll down on my line 30, I do have a scope, meaning that my model Key Vault will be deployed to a different scope, because initially we defined the subscription as a scope. So my first part of this template will be deployed to subscription, and then my model, which is the Key Vault, will be deployed to the scope of the RG, meaning that it will be deployed to this research group. And also, let's take a look at the model itself. So we have a Key Vault Bicep model. So if you go to the Key Vault Bicep model, I have a bunch of things over here as well. So first of all, I do have a Key Vault resource itself. So it's called Microsoft Key Vault Vault. And then I use this API from the 2019. So I provide a Key Vault name. I also provide a location. I also provide the tags, which are taken from my parameters. And I also provide some other attributes. So maybe some of this is a good idea to remove from here and move them away to the parameters, but I just use the default template, considering that these are kind of static things that typically you would keep them as it is. It's like enabled for deployment, enabled for the template deployment, enabled for disk encryption. So these are typical things that you would go with. So then the tenant ID, just to give the scope of tenants that have access to this key vault, and then the access policies. With the access policies, you can actually define who has access to the key vault and to the resources of the key vault. So, for example, I said that within this tenant ID, for this object ID, I would like to give these permissions in secrets, meaning that this object ID is able to read, actually to do all operations with the secrets. And by object ID, I mean the user. So if we go quickly to the Active Directory. So this object ID is actually coming from the parameters. If we scroll all the way up. So first of all, the tenant. So this is what I have hard-coded. Well, not hard-coded, but I define them via the parameters. And then for the object ID, that's the reference to the user, which is executing the command. Because all these deployments that I will do right now from here, they are done on behalf of myself, on behalf of the user that I use, that I actually have authenticated in my command line. So that's the user with the Microsoft account, and to reference this user to give access to the models. Where are my models? Yeah, to give access to the resources in that key vault, I refer by the object ID. So that's how it works. You can also do this to the certificates. You can also do this to the keys, because in the key vault you have this other type of objects that you can store. And also, I do have 3 other components. So I do have a username, so which is this DB user, the DB password, and token. So these are the secrets that I will provide during the deployment. While basically deploying the application. So let me do that first. So maybe let's deploy AZ deployment. What if? So we can also do what if. Let's actually do what if. So what if? We forgot to say that we want SAP deployment SAP what if, and then we say the file itself. So for that we use this init file. So init file, and then we want also parameters. All right, so this is the bare minimum that I need to specify to my deployment. So if I start a deployment, you will see that it will prompt me to type the additional values that I want. So for example, location, etc. So we can also keep specifying them from the command line as well. So with the -p flag and pointing to the file, we can define the parameters from the file, but then we can also define them via specifying them in the command line. Location. So I will use East US 2 because in my subscription, there are some constraints to deploy Azure Postgres. So I wanted to use West Europe, or at least something in Europe, but there are some constraints, and the only place I found which is quite close to my current location is the East US 2, where I could deploy all resources without any problems. But obviously, it's always better to think about from the architecture perspective where your application should be, like who will consume your application, and keep it closer to your consumer. Then I want also to define this DB user, and I will use ABW user, the DB password, and for that I will use, let's say, the secure password, because something like this. And then I also need a token, but I don't want to type token here. So this token is actually for a little bit later stage. So the token is my GitHub token that a static website will use to create the GitHub action workflow, and also creates a environment variable in my GitHub account with the static website webhook token. So this webhook will be used to make an update to my website, and also to do some invalidations, etc. So let's keep it for now without token. I mean, here in the command line, and let's provide a token from here. So I will just grab it from here, and I will put it here. So we started to do the what if right now. So what if will basically show me the output of the change after the applying of this particular template. By the way, because it's already done, as we can see, this is what will happen to my environment after this template application. So let's actually deploy. Let's actually do another thing, which is validate. So this validation is not only for the syntax validation, but also it evaluates the template against some, let's say, Azure tenant constraints, let's say Azure policies, for example, or maybe uniqueness of the resources. If you hard code the key vault name here, like for example, like a key vault. So that key vault is not possible because that's not unique. I believe the key vault as a resource name is already taken. So this validation is really cool. So I suggest you to use what if and also validate, especially in the CI process. So you can test your templates before the deployment, and you can also fail them earlier, so you can address the problem earlier. Okay, so we just did the what if, and we also did the validate. So looks good. And let's create. So let's copy that again. Let's paste it here. So now we just need to wait a little bit and to see so what happened. So maybe a little remark about this Bicep experience in the Visual Studio. So when you type, if you have an extension like I have, so when you type and your file has the Bicep extension and it's properly recognized by the your EDA, so you can do the typing of different resources, and then it will give you the output of bare minimum parameters that you need to pass in order to create that resource. So of course there are more, and those this information you can actually find out in the page with the Azure resource reference for Bicep and IRM templates. So for instance, we are doing the key vault right now. Of course, you can rely on the information that was given to you by this extension, but if you want to do more tuning, or maybe you want to provide more parameters to your templates, you actually go here. So it's a very good document. So the moment you start to work with Bicep, I highly recommend you to bookmark this this page, or actually this set of pages. So you get a reference to all type of resources you can deploy to Azure, and then over here you have a schema for the Bicep. So what exactly the key vault is capable, like what exactly you can define in the template for the key vault. So remember, we took a look into the permissions. So there are permissions for the certificates I mentioned, also the key vault, the secrets, the storage, and then it's an array. So within array, you define the object IDs that have access to this particular key vault, to this particular type of resource. Meanwhile, we've deployed a research group. So the research group is called Azure Bicep Workshop. So let's also quickly validate it via the portal. So yes, we do have that research group over here, but we also have a little bit more. So we also have a key vault. So I just want to make a quick stop here just to explain what we've done. So first of all, we've also deployed the tags along with the resource group. So we have these like the project, X technology dev, the environment, the cost center, the owner of the resource, the purpose, Azure Bicep Workshop. So the location, and we also have a resource, the key vault. Yeah. So if you look at the resource name, so it's kind of odd. But there is some pattern that we actually defined in the parameters. So if I go to the initial bicep template over here, so for the key vault, I defined a resource prefix. So the resource prefix is actually taken from my parameters. So over here, so it's resource prefix. Oh, sorry, it's just one line above. It's ABW, so that's my resource prefix. And if I take a look at this, yeah, indeed, ABW. And then I have a unique string. So the unique string is actually a function. So you can use a lot of different functions in a Bicep template to make your templates reusable and to make your, let's say, the name of the resource unique is one example. So it's actually not a randomizer. It's like a hash, like a base 64 operation on the name of the location. So the location we define via the we basically specify it as a parameter. So remember, we specify the EastUS2. So we just use that unique string on the EastUS2. So we just did a hash for that using the unique string, and then that's why we see those random 13 characters. And then at the end, I have the key vault, like just like a 2 letters key vault for the name of the resource and for the type of the resource. So if we explore that further, if we open up it, we also see there are tags applied. I reuse the same tag object for all my resources in this workshop. So tags I defined, again, this is my text value, and I define that as the object. So I can also change it, redeploy, and the changes will be applied here. So, and if you remember, we also provided 3 secrets to our deployment. So these are the secrets that we received at the end. So we get a username, we get a password, and we get a token. So because I provided the full access to myself, well, to my object ID, the secrets all type of permissions. So I can also go ahead and use this button, so I can actually see the secret value. So remember, we specified that ABW user as the value for the username, and also for the token and password. I can do the same. And by the way, in the access policies, I can see that this is what we define, the access policies. We define it on this tenant, on this object, and we define the permissions. And this is my user. So this is actually the user with that object ID. And then we defined all permissions to that user, like get, list, set, delete, recover, backup, restore. So this is what we defined with the template. All right, I think this part is clear. So what we're going to do next is deploy the rest of our. Let me just quickly. Are there any questions, by the way?
So far, so good, I think. So I'm trying to follow. It's current. A lot of information.
Okay. Was it
I have
was it clear in terms of following?
Yeah, it was amazing. I have a little question, so maybe you can answer that. This story about the key vault and secrets. So you mentioned in the beginning that that will be passed to the web application as environment variables, if I'm not mistaken, on deployment. So yeah, I don't know if you're gonna explain that or show it later, but that is really interesting. I mean, do you define in Bicep a way that they are passed from these deployments to the web app, or yeah?
Mm-hmm. Yeah. Look. So this is how I define them. Actually, we get to the point where we are going to deploy the rest of the infra that we need for the application. And to answer your question, so this is how I refer to this data which is in the key vault, like my secrets, from the web application, and I want to set them as environment variables. So remember, locally we had to set this username and password and host, and then the port and the name, etc. So we will do exactly the same in my web application. So this is my web application resource, and within web application I have what is called the app settings. And within that app settings, I can define the array of environment variables, and I do it like this. So I define the environment variable name and the value, name, value, and of course I can hard code it here. But yeah, why should I do this? So instead, I just do the reference to the data in other models. So for example, here I refer to the login, to the username. Here I refer to the fully qualified domain name of my Postgres. Here I define the password, and I will show you how I define the password, but it's quite secure. So it's basically a reference to the key vault. But yeah, it's coming.
Can you scroll up a little bit? I'm just wondering how you import this PostgreSQL. Yeah, okay.
For the password, yeah, okay, yeah, I can explain. So we also refer this as secure, and if we go to the parent, so maybe I can grab it like this. And if I go to the parent, so basically I have a function which is KV. So KV stands for the resource key vault, and I use the existing method, meaning that my key vault is already there. That's why I actually separated the deployment of the key vault and the rest, because I wanted to supply my username, password, token, etc. in the key vault. And then I used the existing key vault reference. So first I found the key vault name, and then I get the secret like this. So I want to get the secret with the secret name DB password. And indeed, we have this DB password name over here like this, like DB password. So we don't type the password itself, we just type the name of the secret that we want to use.
Nice. Right. Can you define like other ways of passing these settings to application, or like this is a standard and nothing else is supported?
You mean
in a web app part? There was an array of environment variables, and yeah, I'm wondering if there is some alternative on that level, or is just
it's
the default and the generic way.
I think in the template for the environment variables, yeah, that's the way you do it. Of course, you can do it in the portal, just like adding that manually, but why would you do this? Yeah.
Okay.
Yeah. Right. Yeah. I'll go ahead and proceed with the second piece. So now we have this research group, and also we have the key vault in place. So I'm going to deploy the second piece of my environment, and that's going to be basically the rest. So the rest meaning that we will deploy the PostgreSQL, web application, and web application plan. Then it's going to be a static application, managed identity, an Azure Container Registry that will be used for the for my Dockerized Flask application that I will then run on my web app PaaS platform. So by the end of this execution, this is how it should look like. So basically, we get a key vault at the moment, but then we will have the rest of resources in place. Okay, let's go ahead and do it. Let's just close this now for now. Close this one as well. Close this one, this one, this one. I just don't want to make any changes here. So, okay, so we got a main template. So maybe I will just execute it again. So we do it AZ deployment, and at this moment we do the deployment to the group. So let's validate using what if as well, and then let's use the main bicep file, and also we want to use the parameters for the main deployment. So let's explore quickly what we have here for the main deployment file, what parameters we are passing. So we also pass the resource prefix, we also pass the location, we also pass the same list of text. So the problem that I cannot use the same parameters files because it will fail validation because Bicep also validates whether all parameters that you have in your template are in the parameters file, and if there are more or less, it will fail and it will not proceed with the deployment phase. So so let me actually quickly define the group. So yeah, let's just execute this. And let's continue the discussion. Oh yeah, so I also defined the key vault here, but I just left it on purpose because I wanted to show this is how I define my key vault in my deployment. So typically you also can do the reference to the existing key vault like I did in my like I did in the reference to the password for my web application. Okay, so the validation is fine. So let's sorry, the what if is fine. Let's actually do the validate as well. So there are a few things that I want to comment out as well. Okay, so the validation is also good. Let's just create it. Okay, so we executed the creation, and this should take some time. I believe we can spend this time for the for just discussion of the template parameters. So the first thing here, so what is this? In my main deployment file, I do have the model for the Postgres. So maybe I can just close this. Thanks. Now. Yeah, so I do have this model for the Postgres, and I provide the location, capacity, that's the amount of servers I want to run underneath the PostgreSQL name, the tags, these are clear. And then I have a firewall rules. So within firewall rules for the PostgreSQL, I can define the IP CIDRs, or it's actually a start and end, the IP. Which has access to the Postgres. So basically, it's just whitelisting the IP address. So in my parameters, I define this one. Let me just show you. So I think it's Same IP. Yeah, so it didn't change since yesterday. So that's I just defined that for the development purposes. So the moment I have this template deployed with the PostgreSQL, I can immediately start using my PostgreSQL client to get connected to the database. Yeah, just to make sure that everything is good there. You can also define access to your PostgreSQL. Yeah, by, for example, saying that you want to give access to this PostgreSQL endpoint from other Azure resources, and there is a parameter for that. Or you can just keep doing that via defining the values, like setting the firewall rules in your PostgreSQL. And then if we take a look at the PostgreSQL model, because again, in my main templates, I do the model reference to the PostgreSQL, to the Postgres Bicep. And over here, so I have the actual resources. I have the PostgreSQL itself, and I have the firewall rules. So, and the firewall rules, I just use the for loop operation, meaning that everything, because it's an array, so I can do the for loop if I define, let's say, additional set of IPs. So, for example, here, if I define something else in my Bicep template with the for loop, I can basically go through all the rules in array, and I can define the rules in a firewall, and I can also assign them to this parent. So here's how you, by the way, refer to how you do the cross-reference between the models or between the resources. And this is, this is explicit reference, meaning that I do not define it like this. Define depends on, because you can also do it, but oops. Yeah, you can do it like this. PostgreSQL, for example. I think it's like this. Yeah, and then that's going to be implicit reference, meaning that this resource will not start until the creation of the PostgreSQL happen. All right. So there are some other things that I want to highlight in this file. Is basically the outputs. So I use the output with the object PostgreSQL, and I also use the output with the PostgreSQL name. And this information we use in the next step. So we use it, well, not in the next step, but in the other resource that we also deploy. And this is what we use in the web application. So I briefly showed that when I was answering Alex's question. So this is the output that I want to use, or that I use in order to get a reference to my username to get the FQDN for my Postgres. So if I go here, so basically the output is PostgreSQL object PostgreSQL, meaning that it refers to this resource. In the main file, if we take it, let's say the name. So we provide a PostgreSQL name, which we take from the outputs, and we capture that from the outputs. We capture that from the PostgreSQL name output. And then for the PostgreSQL params, we capture also from the output from the PSQL. So from the PSQL, so we provide the whole object, like the whole object, basically the whole thing that has been given to us after creation of this particular resource. Meaning that if we query if we query this PostgreSQL object in Azure, so there will be a big JSON object, and then there are different parameters, and then we can actually refer to those parameters from our Bicep template. So for instance, here PostgreSQL params dot properties dot fully qualified domain name. So this is what we have returned back to us, and under properties we can get the FQDN name, so we can use that as a PostgreSQL or Postgres host environment variable. For the user, we also do like pretty much the same reference, like properties and an administrator login. But because administrator login doesn't have the PostgreSQL host name, I have to come up with like some smart idea. How can I fetch this the host name? So the host name equals to the resource name. So I use the PostgreSQL or PSQL name, which is also the output from from my PostgreSQL model. Yeah, so the rest of the things I just hard-coded, but again, this can be parameterized, or maybe you can use functions to fetch this information from the other places. So we've got this created already. So as we can see, the deployment status is successful. So we can just refresh it and see what we have. So we have a bunch of resources created. We have a key vault, we have a container registry, we have a managed identity, we have app service plan, we have the PostgreSQL with a single server, and we also have static web application and app service. So the app service actually uses the app service plan. So when you create app service, which is platform as a service resource in Azure, it uses the app service plan. Let's just quickly explore this model. So we have this app service plan, which is kind of Linux. So we want to use Linux. And we also use SKU F1, which is free of charge, like a free shared resources. So basically your workload is up and running there, and it's shared with other workloads of other customers. Of course, it's isolated, but there are some, let's say, risks to have insufficient resources at some point, or to hit some credit limits. I mean, the resource limits in the past, it's just free. It's for dev purposes, but it's enough for our exercise. So, and then the next piece here is, so this is the plan. This is basically the resource, which is an app service plan. And the second piece is the actual application, and it's called sites. So we do the reference to the app service plan.id. So this is how we refer to this app service plan again. So we refer it like app service plan.id. And then over here, we also define that where the actual application. So as I said, the application will be Dockerized and will be living. Well, I will Dockerize the application, like build the application using Docker, and then I will push it to the ACR container registry, and I hard-coded the name of the image server and the latest tag. Well, there is some tag obviously assigned to the image, but latest is just like alias, like the latest from the modified perspective in the registry. So at the moment, the application is not there. So this will be our next step. We will build it and we will push it. But there are also some other things. So the app settings that we pushed along to the web application. So let me just go to this app service over here. So this is the typical interface of the app service. Again, we have all the text. So we have this URL. So if you wish, we can quickly check it, whether it runs anything or not. But I believe it's not going to run anything because there is nothing. It will just tell me. Actually, there will be an attempt to pull it, even if you scroll down all the way here. So we have log streams, so you can see what is going on. So typically it streams the everything that is happening on that machine in that web application. So, but I think there is nothing because just because we don't have any Docker image pushed to the ACR yet, and the application error is also here. So what I want to show quickly is the configuration. So just to give you an idea where these values were sent. So this is the configuration of the web app. So basically environment variables of the web applications. And so these are the data that has been added to the to my application server. It's already there. So basically the info part of my application is already prepared. Also some references to my database. So let's do the next step. We will build the application using Docker build command. So let's go back to the server. Let's make sure that we have everything in order. So we haven't changed anything here. No. Oops. Okay, so this is also the requirements txt, also the Docker file. So the Docker file is relatively simple. So probably if you are a Python expert or you use Flask somewhere in production, your Docker file is probably much bigger. Also, there is possibility to use web app or app service to host Python application natively, so you don't need to build that additional layer. So you don't need to Dockerize it and host it there. But I just wanted to have exactly the same experience that I have on my local machine. So I wanted to Dockerize it and see exactly the same what I hear in here. So, and also it's like additional exercise to test other services like ACR, for example. So I will just use it. A little remark. So I use this M1 chipset Mac. So I had to provide a platform that I'm building for. So typically you don't really build your application on a local machine. So for that you use agents, and you use CI, like continuous integration. You build it on the agent somewhere, and then it's a different story. But if you look at my line over here, so it basically contains this additional parameter platform Linux IRM. So that's the only purpose I do it. So the next piece that I need to define here is the Azure CR. But before I do this, let's just quickly see what Azure Container Registries I have available. So this is my Azure Bicep Workshop resource group. And I have this Azure Container Registry, Azure Container Registry resource that I will use to push my image. So first, I want to log into that. Oops. I want to log into that. To that ACR, ACR login -n. So I want to provide the name of the ACR. So this will reuse my existing token stored from the Azure CLI. And that's why I don't need to do something like this, Docker login, provide the credentials, etc. Also, if we just quickly go ahead here, container rich, you will see that I have not enabled this. Well, it's enabled, but actually I can disable that. and it will still work because in my environment I use a managed identity, meaning that let's actually execute the build process. Okay, so I need to specify the correct URL for the ACR. So we build it. We use the platform Linux AMD 64. We built using the Docker file that I just pointed. We also copy the requirements. We run the pip3 install requirements. So basically, we install the Flask course and the model to work with PostgreSQL. And we also copy two files like apps and seed. So for the seed, I use there's a Python way to seed my application with my database with some data. But yeah, let's just copy there. So let's start the build. So basically, it starts to use the Python as a base image, and then it does the rest of the steps. Once the build is done, it will go and push you my IDN. So we will get the image in my registry.
We have some technical issues.
I'm back.
Yeah, good.
Can
Yeah, we can hear you. I'm back.
is good?
All good. Yeah, everything's here.
Okay. At the end of this run, it's probably started to build and push to the registry. So the live streaming for a little bit, but yeah, it's going. It's here to also to mention.
Hey.
How is the quality of my voice? Is it still good?
Yeah, you were, I think, interrupting in like a last minute. I don't know if you were saying something, but we didn't hear almost anything, let's say. But now it should be fine.
Now it's back.
Yeah.
Okay. Yeah, I'm building the image. I think biggest VS part.
Yeah, maybe I can ask something.
Yeah, sure.
Yeah, I have a bunch of questions, I think, but let's choose one for now. Yeah, maybe a simple one. Do you have a repository that we can have a look later at your code and at the Bicep configuration, maybe?
Yep, I do. I think I still need to push it there. But the repository that I showed, that I shared with you
last time, yeah,
you can take a look at that repository. There is just a different branch.
Yeah, I have it. Yeah, nice. All right, that was simple.
And I will push the. I will push the updated after the workshop. I will push it there.
Okay. Is it still building? Do we have a time for other questions then?
Yeah, sure.
All right. Yeah, maybe then Actually, you mentioned that twice, I think, at least this workshop. So, but I did not fully understand that. So, what is you said the last piece of this workshop you're gonna either execute or use GitHub pools or GitHub agents. So, what's the reasoning behind that? Because I thought we do everything in Azure in this environment, and yeah, why do you need an agent pool in GitHub?
Okay. So here, it's my last step. We are going to build the static site. So the static site is the it's the resource to use. Is the resource to host the VueJS, and will be pulled from the GitHub repository. So I have basically this client folder with the VueJS application, and with the GitHub static site pulls that static content and host it over there. So it's just the way static sites work. So when you want to host your static website, so to UI, I think, to show. So that's the new cool service that I will be using. I'm using to host my VS. So if you start creating from the portal, so one of the attributes that you have to define is, well, there are a bunch of attributes, but based on technology, let's say if you say that you are going to host VueJS, or going to have something, I don't know, like React, for example. So one of the parameters defined is source. For the source, we define the GitHub repository. And then because I also can define the token, like a repository token, this creates a GitHub workflow. So the workflow will include several steps to get the code. Well, first to build this VueJS application. Let's say npm build will execute this, and then we'll get the dist folder from the agent, and that's to the static site. So that's the purpose of the GitHub action here. But the overall idea is that I deploy info and I deploy application using the GitHub actions. So the only purpose I do it locally right now on my machine, because this is much easier to understand, much easier to follow. But all of these steps you typically
But
do,
alternatively, you could also
else,
use Azure DevOps. Is that correct? I mean,
oh
instead
yes,
of GitHub Actions.
Yeah, for sure.
Mm-hmm.
Exactly. So here, so you define the organization, project repository, the branch, and then basically the static website will take this content, will build it, will get the build directory that has to be published, and that do the resource, static site resource. In fact, it's just a blob storage underneath with some smart connections. So that's the way it works. So 2 years ago, how I can do static websites in there, and I was looking into blob storage plus some CDN resources to cache the content across the world using basically the access to say images or media content can be done faster, and also it's kind of our idea is just much easier to use, and I was just the idea of either GitHub or Azure DevOps or any other your own Git is that this source for the static is taken from there.
I see. I see. Thanks. Thanks for that. How is your image? Is it built or still working?
Yeah, almost there. I think that it's pushing, so you still few layers left. I think what we can now, what we can do now, we can look into the database, because we also want to see some data in the database. Actually do this. So I do have this still building. Let's just leave it for. So let's just connect to the database. Again, because we defined. Yes, I don't want it. Again, because via the firewall defines my is allowed to access this database from my. So my next step would be to this SQL, to this PostgreSQL, and create the tables, and I will also seed some data. Refresh list of resources here. All right, so we get this Azure SQL, Azure PostgreSQL. Okay, so this is my server name. So for the server name, and for the user, I will get this user from here. Now I will put it here. And for the password, because well, of course I provided the password, but I think special characters like $sign. I think there is some escape special symbols, and the password in fact was saved differently, but we can luckily develop the password because we have full access to the secrets, which is kind of okay. So I have this DB password. Let's take a look at this. We get a show. Yes, that's what I thought. If you remember, we specified this $1. Then instead we received this because anyway. So let's do the remote PostgreSQL. So now we are in use in East US 2 data center. So all the databases. So these are the databases that we have. Looks like it works. And now I want to sheet some data. I don't remember that by heart, as I said. I will just quickly go ahead here. So I will do the following. So I will restore, because I have again have that SQL stuff over here. So I want to create a database, and then I want to create a table with some data that my Python application will use in a moment. So for that, I will do the PSQL SSL mode equals to require, because it's in our PostgreSQL here, the connection settings enforce SSL connection. So basically, it requires to have a self to this instance. So then for host we take the value from here, and we define for user we take the value from here. Now that we want to see it, and then we find the that we want to use. I wouldn't use it as like. Anyways, so we get a password request and we go for the password again. So what we are doing now, we basically are running this SQL against our PostgreSQL in Azure, meaning that we want to create a database, we want to create a table with books, and we also with 3 books in the database. Going on here, so it looks like the final piece for the here. So forgive me, I'm just in a slow bandwidth, so that's why it takes some time, but typically it's. So yeah, we create in a database.
Yeah, I guess it also affects your network a little bit, but that is okay. Do we have time for other question, you think?
Yep.
Yeah, I was wondering in this bicep template, so if that is correct name for that. Yeah, so when you create a resource, you specify the name of resource or the variable name for resource, and then you have a string. And this string is that includes also like a type that Azure knows, so the type that Azure recognizes, or it's just a random string that doesn't mean anything.
Yeah, so actually there are a few. So let me just show you here. So there are several data types that you define when you create a. So bicep supports A. So we saw the firewall rule. We defined an array, an int, then object, then string. So you also define it typically like this. You say param, and at the param basically I want to define array with the firewall rules like this. Okay, fine. There are also 2 other things: secure object and secure settings. Secure string. So we secure string like this. So use the we use the secure to say that this is the DB and this is secure, meaning that if there is a prompt to define the value, always hidden, and you will need to type it, but nobody will see it, and then you refer this parameter from the key vault. So basically, you can take the data from the key vault, like we did for the username. But yeah, these are the type of.
Can you open maybe the
data?
Yeah.
Yeah.
Can you please open the DB template? I don't remember the name. I was asking a little bit about different stuff. Yeah, in here, yeah, when you define resource, I guess, then you say PostgreSQL right on top, and then you specify this long string, and it says Microsoft Azure, Postgre, blah, 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 and then a date. So I was wondering about this string afterwards. Yeah. So how?
Oh, okay.
The
so
meaning.
This one is okay. So this one is actually, one sec, yeah, it's this stuff. So basically, you define a resource, and in that line you can also define the symbolic name, and you define which is inside the string, and also inside that string. So the place you take this data is actually here. So for example, for the key vault, or let's actually Postgres. So you to servers. So you get, first of all, you get a rep different API versions, let's say latest or maybe a specific version that you need, and then first itself. So typically you define a resource like this. It's Microsoft, and then a resource which is taken from the web, and then you define the sub-resource. Let's say in PostgreSQL you have servers, you have also Flask servers, you have some other stuff, and then the API version. So that's how you do that. That's a standard way of working. That's how you should reference to the resource in Bicep resource.
All right. Yeah, it's clear now. Yeah, thanks. Yeah, maybe while we still building another small one on database. So when you showed it locally first, right? You starting your PostgreSQL container, and then you have your local setup, local environment to see if your application is working correctly. But then in Azure, actually, you start up a service for Postgre. So my question would be. You always find a resource in Azure that you can create for database, right? You don't just spawn a container with a PostgreSQL that you download from a Docker Hub, right? You need this service in Azure, or it's also common that you can, I don't know, bring in your database as an image and then spawn it as a part of your application.
Yeah, I think depends on application and depends on the company. Probably it's not a good idea to use the let's say a container application or a container instance service in Azure to run a single Docker instance or a single Docker host your database, because it's all about the highly available database. How would you do the available database? Then how would you do the backup? How would you do the restore of the database? So basically all this management stuff around this, how would you be a fan of this? If you really want to do it, probably you would follow this path. It stops you to, let's say, spin up a virtual machine and install PostgreSQL there and manage that PostgreSQL yourself. But if as a developer you want to focus on your application, and you want to focus on the underlying infrastructure, you would choose something else, like for example this managed SQL, managed PostgreSQL.
Yeah, makes sense, of course. Yeah. So, and for most of the databases, of course, you have that kind of resources in Azure, so you can just spawn them and start them for your application.
Yeah. So, in the project that I've been working in, so I've seen a lot of Cosmos DB. So Cosmos DB, so it offers you to use different APIs. If you have MongoDB, for example, you can use this API. If you have like Azure SQL or Microsoft SQL, you can also use Cosmos DB out of the box. So it's like you create a resource, and then with different tweaks and parameters, you define what out of it. In this case, indeed, I prefer to use Postgres just because it's easy to follow, and it's quite a standard reason. But in Azure, there are different choices, indeed. So you can basically, pick the choice that you like. Yeah. So it's almost, I think I could just spotlight again. Let's give it some time.
Yeah. Just small questions and.
Yeah. I think what would be nice also to highlight is the following. So we get what is called a managed identity. Yeah. I also define. By the way, do you see my screen?
Yeah, it's all good. Yeah. It's a little bit delayed.
So while we actually run this build, so cool. Use this managed identity over here. So the reason I use it because so what is called a built-in role. If you open this website for the built-in role, what we can see there is the all enrolled by Microsoft. That for example in here in this workshop, I use the built-in role called ACR pool. So this role allows to pull artifacts from the container because my registry, so I don't have enabled as we saw the administrator access use the username and password. We don't store them. So instead, we use a identity for that. The proper role has to be assigned to a proper scope. So for that, what we do, we basically use this ACR pool role, and there's a reference to this role. What we have here. So we first check the existing pool definition behind it, and we store it in this symbolic name. The second thing, we create a managed C itself. So the managed identity by the citizen of the Azure Active Directory is like a principal, a similar thing. It's like a user identity instance. So this is a managed identity. And then the final step, we do role assignment. So what it means, behind the ACR pool to the managed identity on the scope of the ACR itself. But the ACR scope is not here, is not supported. So it goes to the resource group name, meaning that every resource with this managed identity, this resource group can pull images from my container registry. Yeah, by the way, it's done now. It should be much better voice quality, and I do apologize about this part again. So this is ACR pool. So basically, what I'm trying to achieve here, I'm trying to give the web application the following parameter. So I defined, so this is the scope, this is the resource definition for my web application. And underneath what I have here, so first of all, I identify the reference to my managed identity, meaning that if I go here to the application service, if I go to identity, in user identity, you have this reference. So I can define as many user assigned identity as I want. There are some there of managed identity. So first is system assigned identity, which is assigned by Azure. So typically it's for one purpose. Like let's say if you create a virtual machine, and virtual machine has some other components like a virtual network interface, a network security group, a disk, etc., a snapshot, for example. So with the system-side identity, you can connect all these components together, and this is done underneath because Azure actually has this multi-component approach. And then the user assigned identity is when you, as an architect, as an engineer, would like to get the credential-less communication between two resources, let's say ACR and web application, like we do right now. So you can define first the managed identity itself, then define the role that this managed identity should get, because you can also keep defining another role definitions, and you can also add them to your managed identity, meaning that you will have custom managed identity even with a custom policy. And then you define it to the scope of resource that needs access to a certain target. So again, in this case, we want our application service to work with the ACR, basically to pull image without any credentials. So as the image is already there, we can just quickly check it. In the container registry, in the repositories, so we should be able to see our server. So again, the server is the application, like a Flask application, which is there. So now we should be able to pull it, because there's another piece. So we also said that we want to ACR use many credentials, true. And we also define the ID of our ACR. So basically it points to the client ID of my managed identity, which has ACR pull built-in role assigned. So meaning that my web application will use that managed identity and will pull images from that registry. So now another remark: if you wouldn't do this part, and you would need to come up with something like this. So you would need to provide the credentials to your host here, then the username, the Docker user, the user, etc., etc. So, and you will need to enable the username and password access to your ACR, and then you will need to handle those credentials over here. And instead, this managed identity is really cool. So you don't really need that. That's kind of connecting all these pieces together for you. And it also uses that least privilege approach, because you define what exact roles you want. So let's just super quickly explore what is happening there, because the image has been pulled, has been pushed to the registry, and I think what we need to do now is to check what is going on here. So maybe we can point that immediately to this health endpoint. Remember, we have health endpoints for our Python application. So we'll do fetch this URL now. So let's see if there's anything happening. Meanwhile, let's quickly check what is going with my database. Let's get the password. So what we're doing right now, we are seeding the database with the content from here. And at the same time, I am watching my web application if it actually pulls the new image from the registry. So yeah, just doing two things at a time so you don't be confused, but yeah. All right, so we created database. We also inserted tables. Cool. I think this part is done. Let's just quickly double check it. Oops. Okay, so we want to connect to this. Oops. We want to connect to this ABWDBA. All right, and then we want to select books again, just to make sure that it's there. So we've just corrected it's there. So this is all good. So we can just leave it. So what is happening here? Let's take a look at this point. So we can see that the image has been successfully fetched. Let's just make sure that we are in the correct place. So we have this URL. So we have this health. All right, so remember we had this endpoint with the health. So again, if we go to this server, we go to the routes, we get this health URL. So all good, all perfect. And then let's just double check in the deployment center what exactly happened there. So in the deployment center of the application, what we defined in the template, so that we wanted to use, maybe it's also a good idea quickly to open it. So we pointed to the Linux FX version, to the Docker ACR login, to the server, to the latest. So that's exactly what we see here. So we have the reference to the registry, over here. And then we have server and latest defined over here. So we also use the managed identity to pull it, which is defined over here. So on the identity, we define it on line 63 and 64. So it's basically identity and then pointing to the registry. So all good. So this part is also done. There's one little piece. Let's see if our application actually is pulling images from the database. I just use this books get method. Apparently it's not, and I think I know what's the problem, because we didn't set. We didn't define the security access for everything, and this is a little bit odd because what I discovered, if I go to here, so I actually define that access, public network access to enabled. I expect that to be in place. So might be a bug. So I actually had to do that manually from the portal. That's the only step that I want to kind of like solve by this shortcut. I apologize. I just couldn't really figure out what's the parameter I have to pass over here, because I'm passing that public network access to be enabled, and it doesn't really understand it for some reason. Not sure. Anyway, so if we, you see, so we just define that access to Azure services. So basically it starts immediately working. So we can see that API is actually fetching all the data that we need. All right, so by now what we have, so we have a database with the connection that allows connection from all Azure resources, not only mine but also from others as well, which is kind of dangerous. And normally you wouldn't do this. You would really think about security, think about the whitelisting, think about maybe communication in the private network. But then it will need to have. It will also need to have your validation deployed to the VNet, and also integrate the Azure SQL database with the virtual network. But it's I haven't done it here in this workshop just because these are the higher tiers, more expensive type of resources. Okay, so can you hear now?
Yeah, and it's a little bit even better. I think it's a different kind of sound, but yeah, we can hear you.
Yeah, perfect. So my headset they just they don't want to in. I'll just switch to the built-in microphone in the laptop. All right, so now we have a database and we have our sites part up and running. So everything looks good. At least my Flask application is getting data from my database, which is good. Okay, so I think it's time to look to the final. So the final piece is my static web application. So let's just go ahead here. And let's see what is going in this model. Let's start from the beginning. Let's here. So in the main template, we have a reference to the model, and it's so we just, as always, give it a name, location, tags, and also we give three additional parameters: repository token, repository URL, and the branch. So the static site is basically the resource in Azure that helps you to run your static content. Static site, let's say Hook or Jekyll. Might be a question, why should I bother? Because I have a lot of other alternatives for that, but anyway, it's there. You can also host your VueJS, as I said, React, and any sort of typical client type of applications, or mainly JavaScript type of applications that you can host over there. So those three parameters that you define are the parameters that will help static websites or static sites resource to understand the content. And also the static site resource is smart enough because it understands what type of application you have there, and it also provides the steps to build this application. So the reason why we specify the token, and because if we go further to the static site, we see that with additional parameters, I also specify the provider. So I can also use Azure DevOps, or I can choose other, or in this case, I selected GitHub. And I can also specify the repository token, and I can also
define some other things like where the application is. So in that repository, I have application in the clients folder, and also the destination for the build, because when I do npm build for my VueJS, the content will be stored in my dist folder. But I don't push it to Git. So instead, this is all happening on the GitHub. So the main reason why I define why I provide a token is that Azure also goes to your GitHub. It creates a token to do the updates of the website let me show you. So we've got here static web app resource that I generated using this model, using this resource. So let me just get the URL, paste it here. So it has this VueJS application that is already in my GitHub. So also we have some reference from the application. So we have first, so if you click here, so it brings me immediately to this first challenge branch. There's a client folder. And in that client folder, I have the content of my VueJS application. So there's a public CRC directory and some other JSON files. So also there is a reference to the workflow that the static website creates for me in my GitHub Actions. Let's see what happened. So, and as we see, it was executed 1 hour ago, exactly when we executed the deployment of the whole, like of this big blast second part of the resources, like the web application, static website, key vault, managed identity, etc., etc. For some reason, it created 3 workloads for me. Not sure. I need to explore, but I think this one and this one failed because this one was executing. And if we explore the steps, we will find out that there's a checkout. So basically, it gets the code from the branch that I defined, because as I said, it's smart enough, so it understands what sort of application you have there. So it also knows how to build it. So it uses a node of the version that is defined in my package.json file, and it installs all the components. And basically, it starts the build process like npm build, and at the end, it posts that in the dist folder and makes it available as an artifact. So this is basically what it does. And then the final piece, it also uses some sort of maybe Azure CLI or plugin that pushes that to the dist folder to the static sites resource disk or resource storage. And as I stated, it's actually a blob storage, so it just posted there. We just don't see it because it's a managed resource, but basically it takes the content and brings it there. I think there is a problem because the version of the static sites in my Git repository is the old one. So it actually points to some API, which is like I was running beforehand, like which I was running earlier. So maybe let's just do this quick change so we point to the correct to the correct API. For that, we will need a URL of our web application. So that's the first piece. Okay, it's there. So I use it as a proxy. So I connect my client and my server. And then for here, I also use this URL. So maybe I can just do it like this. And also for my main for my main set of methods, I use the other one. So I'll just do it like this. I'll just submit it to the And by the way, these are the workflows that Azure automatically creates when we create the static web site resource. So basically, it creates the workflow that includes a job to build and deploy the static web application. There is a checkout. There is a build point. So basically, it builds the application, uses the Git token. For that, also there is a token to the web app itself, so it has access to the endpoint where to submit the payload with the change. And once it's done, it basically updates the static website content with the content which is in that dist folder. So that's the purpose of token that was submitted or was provided on the creation of the template. So I am merging again. I think it's just a duplication. So one of these tasks should be failed very soon, but at some point we will get the application up and running over here. So and references from the clients to the proper endpoint. So if we try to add something, maybe first I will do it like this. So yeah, as I said, there is another instance of my API server up and running. So this client is fetching the content from there, but we just submitted the change, and this change should be merged and should be published very soon. I think this one should be successful. Yeah, it's building and deploying. I hope this one will be successful. Yes. So let's see. All right, so this looks promising now because I think it's actually fetching that from the right location. Yeah, indeed. It's fetching that from the right. Yeah, it's fetching that from here. So let's do the books. So let's do the books update. So maybe another limited memory. Another attempt to do some John Smith. Did I read the book? Yes, I read the book. Okay, cool. Yeah, it's there. So maybe for the audience, if you guys have any book that you want to share with us. So how do I post it? Maybe I can post it to you guys, and then you can post it to the audience. So you guys can see the book that you like, and I can see more books.
Let's do that. Yeah, indeed.
Yeah, but yeah, I think it was a bit chaotic, and then yeah, the choice of resources, especially for the clients, maybe you can explore what other resources are available for the client. But again, the main purpose of this workshop was to explore what Bicep can do for you and how you actually can deploy the application like this, like full stack application. You get a client, you get a server, you get a PostgreSQL. And then you have also the container registry, managed identity that all work together in order to get it in secure and faster way. So I think yeah, that kind of concludes the whole workshop.
Evgeny, that were really intense. I mean, it's a huge. I think we covered a lot. Like I can't even say how grateful I am to be honest, because it's yeah, it really covers like from local development sort of things to to like a full journey to cloud, including database, client, and the server-side application. It was really nice, I think. I have just a little questions left. I think most of it we already covered during the workshop. I have some of them are. I think only dummy left. Maybe just quickly compare with some other instruments. Like we discussed it last time a little bit about Pulumi, right? We have Pulumi, we have Terraform, and Bicep is a specific tool for Azure. So can you maybe do a quick summary when you would prefer to use Pulumi, for example, or Terraform, and when you would prefer to use a Bicep instead?
Yeah, I think it depends on experience, depends on existing infrastructure, and also depends on the future maintenance, really. I would consider to use Bicep if there is existing, let's say, there's existing set of engineers with a good experience of Azure, and maybe they have some concerns about IRM because of those disadvantages, as I mentioned. Let's say there's complexity, hard to maintain those templates because of syntax, etc. And they want to get some sort of new way of working. So Bicep probably is a good way to explore further. But again, so we need to discuss, we need to check what is the end goal, what we want to achieve. Maybe we want to explore Terraform or Pulumi or any other way of working, or maybe we want to use some like oven vending way of working, like use the REST API. It all depends, really. So there is no single correct answer for that. But what I see is there is a good feedback from the engineers and architects who are using IRM templates or who used to work with IRM templates heavily. And this Bicep way of working is much simpler because you can just modularize, build templates, and easy to follow them, easy to explain them. You can also store them in different locations like repository, like these template specs. You can reuse them. Yeah, it's kind of really cool. But it really depends. It's like, it's like a question: what's your preference in terms of cars? Like which car you prefer, and then we start talking about like why this model or why that model. So it's really the preference. It's really about this.
Yeah, makes sense. Another one also maybe Pulumi related, because we explored it lately, let's say. So in Pulumi, I imagine it like as an intermediate layer, and that's why it actually can act as a with different cloud providers. That is, I guess, one of the big differences with a Bicep, for example. So with Pulumi, you have this intermediate platform that stores the state of your deployments. And I think in Bicep is something like that, but because it's fully Azure, it actually doesn't have this layer that keeps a state somewhere between. I think the whole state of your deployment is directly in Azure. Is that correct? Does it make sense?
Correct. Yeah. So the Azure Resource Manager keeps the state of your deployment, so it's all there, and you don't need to keep any cache or. Yeah, in Terraform, for example, you have this Terraform state file, and even if you go to Azure, so you have to, in your parameters, you have to define the storage. Like typically, is a blob storage, like Azure Blob Storage account, where the state file will be kept. And I think it's quite crucial to have this file backed up, because I'm not sure about the consequences, but I think there is some way to restore the state if you lose the file. But I've heard some bad stories from my colleagues who actually have it. So this I'm not saying that the state file is bad. I'm just saying that in Bicep is slightly different. So it's the state is actually kept in Azure Resource Manager.
All right, Igor, you have any question? I know you have one at least. I can I can say it for you.
One.
Yeah.
Yeah, I mean, honestly, I'm super overwhelmed because like this is a super interesting topic for me, and now I almost can deploy my application, at least in Azure, if I follow the same procedure. So thanks a lot, Evgeny.
Yep.
Yeah.
Yeah, I think in the beginning, Igor asked, how did you get these drawings? Did you do it
Exactly.
yourself? Yeah.
There's actually a nice. I watched some YouTube videos with the architecture explanation, and I saw there was a nice. I will show you. So just quickly to share that. It's like it's not an advertisement.
Yeah.
xcalidraw.com. I'm not sure about whether it's like planning or something, but I really like it. So, for example, yeah, it's like an endless namespace or whatever. So all the pictures that I created like here. But I like it's like look like if you do it like this, and then you can also do it like this. It's like a handwriting. Yeah, really cool.
Yeah.
So
Yeah.
yeah.
Add it to my bookmarks immediately. Thanks.
Yeah, sometimes you can stick, of course, with those the regular, especially corporate tools like Visio from Microsoft, or maybe Lucid Charts or Draw.io. But I also like to explore other things, like what is available. So this popped up recently, and I liked it.
Okay, last question from my side. You planning a conference talk for that, or where can we see maybe something like that in your, of course, from your side?
Yeah, maybe I'm interested in put it a little bit further, but I think it's too much at the same time. So maybe it's either simplified, but if you simplify it, then it's like too less. But yeah, definitely yes. I need to think about a format and what's the approach, because now we are like 2.5 hours.
Yeah,
So,
that's not. It's you know that they have usually this workshop formats again in conferences, and I think this perfectly fits, to be honest, on different kind of conferences for that.
Yeah, but we'll see.
All right, thanks again. Any final word from you, from both of you?
Yeah, from my side, I hope you guys enjoy, especially attendees, and you was able to follow me. Sorry about some technical problems on the way, but I was trying to keep an eye on the key points. I will try to structure everything properly, so it will be easier to follow afterwards, and I will publish that to the repository that Alex mentioned already. Also, feel free to to publish that to your place, and then you can share that learning experience. And I hope you was able to catch it. So enjoy.
Thanks.
Thank you, Evgeny. It was really impressive.
Yeah.
Thanks.
All right, then everyone have a good weekend. Have a good Saturday.
Yeah.
Cheers.
Cheers.